Okay, so jumping into another problem here, we have minus 4 x plus 1 in brackets into x minus 2. Now, if we were to ask how many terms in this expression, we'd say one term, right? Just like here, how many terms are in this expression? We'd say one term. How many terms in this expression? One. Term, one. Term, one. Hence, we refer to these as monomials, all right? But of course, our approach will be different for each monomial. We apply FOIL here because we recognize that there are two terms inside the bracket. Two times inside the bracket, two times inside the bracket, two terms inside the bracket, two terms inside the bracket. All right, this here, all right, is a squared minus 1 over a squared, the whole thing squared, right? So obviously we would first and foremost, because we can see that there's a square here, we would open two beautiful brackets. Okay, very, very important. Okay, then we would actually go ahead and apply first and foremost FOIL. Okay, then the 2 would await the completion of FOIL first, and then we would distribute the 2 thereafter. Very, very important. So let's go a squared times a squared. Okay, positive times positive is positive, 1 times 1 is 1, a squared, a to the power 2 plus 2, which is 4. Now the thing is, you might be wondering, why don't I put the positive and the 1? Remember that positive and the 1 can remain invisible as long as there is a variable. If the variable is there, we don't have to really write the 1 and the positive there. But if the a to the power 4, the variable was not there, we would have to write the 1 down. Okay, I hope that makes sense if there wasn't. Okay, so then a squared times minus 1 over a squared, positive times a negative is negative. Then you can see there's a squared times 1 over a squared. So 1 times 1 is obviously going to give us what? 1, right? But then the a squared that is in the numerator times the a squared that is in the denominator, that's like a squared divided by a squared. What does that give you? It gives us 1. Okay, then inner terms, negative times a positive is also negative, 1 times positive 1 is also 1, and then a squared is in the denominator, this a squared is in the numerator, a squared divided by a squared gives us a 1 as well. And lastly, negative times a negative is positive, 1 times 1 is 1, a squared and this a squared are both in the denominator, so that means we keep the variable, we add the exponents in the denominator, it's a to the power 4. Then finally, we get a to the power 4. What's negative 1 times negative? What's negative 1 minus 1? Okay, because we are adding like terms. Sorry for the siren. Minus 2 plus 1 over a to the power 4. Okay, I think that siren was definitely a siren to sort of like remind us that, guys, with this sort of problem, you see this exponent here? 2. This exponent here, we always open two brackets when we can clearly see that inside the bracket there are two terms, and these two terms we need to actually apply FOIL to the two terms first. Then, all right, remember what I had said that this 2 does not fall away, it was there always waiting. All right, now we can actually distribute the 2 all the way. All right, so that siren was just a reminder to us that, hey, do not forget that you had a 2, right? So whilst you are busy with applying FOIL for these two open brackets, don't forget that there was a 2 waiting on the outside. So now we can distribute the 2. 2 times a to the power 4, we apply S and L again. Positive times a positive is positive. 2 times, there's an invisible 1 there. 2 times 1 is 2. And then the variable and its exponent next door. Positive times a negative, negative. 2 times 2 is 4. All right, and there's nothing else that we can do. Obviously, there's no variable. Then 2 times 1 over 4. Remember, this 2 is going to be multiplied with the numerator because this 2 is actually in the numerator. So 2 times 1, positive 2. Then the a to the power 4 just remains in that denominator as it actually was. And there we have it. The answer is 2a to the power 4 minus 4 plus 2a to the power 4. Now someone may think, sir, aren't these like terms? No, the thing is, this a variable and its exponent is in the denominator. This variable and this exponent is in the numerator. So basically those are 3 separate terms 1, 2, 3 apart, and they stay that way. Okay, hopefully that was not too shabby. Hey Nige. All right. Okay, I think let's go ahead and actually do this one as well. This minus 4 into x plus 1 into x minus 2, since we are basically doing problems that have a coefficient, all right, and two brackets that are multiplied together, which are monomials, but inside we have binomials. So let's go. So what did we say? We just apply FOIL for the two brackets, and then -4 awaits its entry after FOIL has been complete. So let's go. Positive times a positive, positive. 1 times 1 is 1, x squared, x squared. So we keep the -4 outside, and we just open a bracket so that we can complete what is on the inside. So that's x times x, that's x squared. X times -2, we distribute that. Positive times a negative, negative. 1 times 2, that gives us 2, and the x is placed next door. Inner terms, positive times a positive, positive. 1 times 1, 1. The x next door. Remember, we didn't have to really write down this one. We could have chosen not to write it because the x variable is there, so the 1 can remain invisible, but it's fine. It's not wrong if we do that. Positive times a negative is a negative. 1 times 2, that's 2. You close the bracket. Then ultimately, what do we see here? Now inside the bracket we just sort out the like terms because they are there. So let's just retain the x squared. -2x plus x. Remember, when you add like terms, we keep the variable, we add the coefficients. -2 plus 1 gives you -1, but we can just write negative, okay? X, the 1 is there, remaining invisible. If we write the 1, it's not a train smash, it's not wrong. Then the -2 there. Now we have added the like terms. Now the -4 is ready to be distributed to each individual term, because there are 3 terms inside the bracket that the -4 can be distributed to. Negative times a positive, negative. 4 times 1, 4. X squared next door. Negative times a negative, positive. 4 times the invisible 1, that's 4. The x next door combined. Negative times a negative, positive. 4 times 2, 8. Voila, done and dusted. Not too shabby, hey Naj. Okay, guys, I hope you can see how easy and how really simple all of this monomial and algebraic expression products are. Okay, have a great one.